Okay, so I need you guys to review your significant figures, not only for your semester exam, but for the rest of the year. Now we're actually at the fun part of chemistry, in my opinion, where you actually get to do your reactions and figure things out and problem solve and stuff like that. So I just wanted to review your significant figure stuff. We're only going to be focusing on numbers 1 through 3 today. So I'm going to do number 1 with you because I think it's most important to know that you guys remember what a significant figure is. And then 2 and 3, I'm going to kind of let you guys practice on your own after I give you an example. Okay? So number 1 is all about defining your significant figure. So can you guys remind me what a significant figure is, or what we count as a significant figure? And then we're just going to go ahead and write it in the top corner. Good. Okay. Let's start with that one. I like that one. All non-zeros. Okay. Okay, so sandwich zeros count. Does everyone understand what I mean when I say sandwich zero? Okay, so something stuck in the middle. Okay, so we have a number, 0, number. Okay, trailing zeros, do they always count?
If there's a decimal.
Good, if there's a decimal.
Leading zeros don't count.
And then finally, good. Never leading zeros. Never, 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 never. Okay, so using that, let's do A and D together at least. Okay, so A, super easy. You guys got it? How many are there? 3, good, okay. And then letter D, how many are there? There's only 1. These first zeros do not count, so there's only 1. All right, you guys try and do the last 4, and then we'll check it in about a minute, okay? Okay, you guys ready to check them? So letter B, how many did you guys say? There are 5. Trailing zeros count because there's a decimal right there. Okay?
If it was 8.000, would it still be 5?
Yes. Yep. All right, how about letter C? There's only 2. There's no decimal anywhere in this number. Okay, letter E, 3, that's your sandwich 0. And then letter F, there's only 1. Okay, when you're in scientific notation, they put it in scientific notation to make sure they have it in the correct sig figs. That's the whole reason we even use it. Okay, so only count whatever number they give you. Okay, don't worry about moving the decimal or anything like that. Okay, even if we did move the decimal, it would have looked like this, right? So do those zeros even count? No, right? So it's just 1. All right, cool. So the next section is about taking an answer that you would get from some calculation and making sure you can round it to the correct number of significant figures so that we can make sure we can still do sig fig math. So number 2, okay, 5 and up, what do we do? You round up, right? And then 4 and below stay the same. I'm just going to write same. Oh my goodness, I'm running out of room. Okay, cool. So the way you're going to approach this, it's really not too bad. You're going to I'm going to do the whole top row with you, and you're just going to keep using the number before, okay? So this says it wants it to 4 significant figures. So what I'm going to do is I'm going to count in my original number. I'm going to say 1, 2, 3, 4. I'm going to underline my number 3 right there, okay? The 4th significant figure, which happens to be a 3. And then I'm going to check the guy behind it. It happens to be a 1. So what does that mean? Stays the same. So my 4 significant figure answer is going to be 84.63. Now they want it in 3 significant figures. So I'm just going to use my answer right here. I'm going to say 1, 2, 3. I'm going to underline my 6. Check the 3 behind it, and that tells me that it gets rounded to what? 84.6. We're staying the same. Okay? Then for 2 significant figures, I'm going to go to 1, 2, check the 6. What does that go to? 85. And then our last one, we're going to check 1 sig fig. The guy behind it goes to 90. Biggest mistake people like to make is they just put a 9 because they know it's 1 significant figure, but you can't lose what the actual value is. Okay, it was 90. Okay, so that's your example for that one. Okay, and you guys will practice that in a second. Let's go ahead and take a look at number 3. The third part is about doing your little sig fig math. So there are I'm sorry, I keep moving the screen. Give me 1 second. All right, there you go. All right. So there's 2 different sections, right? 2 different types of problems that you have. What were they? Yeah, exactly. So you either had multiplication and division, or you had addition and subtraction. So let's start with our multiplication and division. When you are multiplying and dividing, okay, your answer should reflect what? Who remembers? Your lowest number of sig figs. Good. Okay, so let's go ahead and take a look at the first example. So I have 8.2 centimeters, 6.08 centimeters, and 15 centimeters. Okay, what should I do before I type in my calculator? Count your sig figs, exactly. So 8.2 has how many significant figures? 2. 6.08 has 3. 15.0 has 3. Trailing 0 with a decimal. Trailing 0 with a decimal. Okay? So looking here, what should my answer reflect? 2. So our answer should have only 200, not 200, 2 significant figures. Okay? So just to save us time, the answer that you would get on your calculator would be 747.84. Okay? I need it to 2 sig figs. So I'm going to go count over. Actually, you guys go ahead and try it first. Try and get your answer to 2 sig figs. And put the right units on it. Okay, so hopefully you got 750. Yes? Sweet. And then your units are going to be centimeter cubed. And I just got that from centimeter times centimeter times centimeter. Okay? All right. So our other category over there was addition and subtraction. Okay? So for addition and subtraction, we know that our answer should reflect what? Good. Lowest decimal place. So now we're counting how far after the decimal we go. So for this one, we have 23.4. So that's how many decimal places? 1. Okay, 8.4 has 1. When you type that into the calculator, what would show up on your calculator is this. Is that correct?
No, you want
You want it to be 15.0. Does that make sense? So you have to take it to that decimal place. Okay? All right. So I'm going to give you guys about 3 minutes to kind of practice some of these. And then we're going to flip it over. I'm going to tell you what the molar mass is. And then the rest of the time is for our pre-lab. Okay? We're all good? Sweet. All right. Go ahead and practice for about 3 minutes. Now is also a good time to get a calculator if you don't have one on your desk, because the next slide you guys are going to add a bunch of stuff together.
So let me use your restroom.
Hmm?
Use your restroom.
All right, back. Woo, whoopsie, didn't mean to do that. All right, so looking at the back, you guys have a nice little description, and honestly, I don't feel like I need to. All right, I don't really think I need to walk you through too much of this. A lot of you guys are gonna be like, oh, yeah, I probably already knew that, and that's cool. So what I need you guys to be prepared to do after our lab is knowing your molar masses pretty quickly, okay? And so what that is you're going to be using your periodic table, and you're just going to basically be adding them up. You already know how to count atoms when you look at something like a molecule, like CO2. You know that it's 1 carbon and there's 2 oxygens, right? That's not news to you, hopefully. I really hope so. Okay. I know, right? Okay, so when you're doing molar masses, the coefficients, that doesn't matter. Okay, so don't worry about that. You always just look at what the molecule is. And this kind of walks you through on the example what to do. So for carbon dioxide, which is your first line down in the table, so you can even write down some of it in the table if you want to just follow along with it. It says there's 1 carbon, 2 oxygen. So their molar mass for carbon is 12.011. Okay? And so you're going to add that to 2 oxygen atoms, which is 15.999. Now, since we just reviewed sig figs, this 2 right here that they're showing you, you can see it? It doesn't count. That's not your significant figure. Those are numbers that we are just using to figure things out. It's a ratio, so we don't ever count those, okay? What you do want to pay attention to is how many decimal places should your answer reflect if you're adding those 2 numbers together. 3, okay? And so make sure your answer reflects that. And then when we start doing stoichiometry and the fun stuff, you always want to be checking what decimal places are we doing. Are we multiplying, dividing, or are we adding things up, okay? All right, so pretty much all your answers are going to go to the 3rd decimal place because everything on your periodic table does. Does that make sense? Yeah? Okay. So go ahead, and what I want you guys to try to do is I would like you guys to try to calculate at least 5 of these. Okay? At least 5 of these. And when I say 5 of these, I don't want you to skip the hard ones. Make sure you do aluminum carbonate. That's a good one to do. Okay, and then, yeah, first 5 are good. Just do the first 5, and as soon as we're done with that, we're going to start our pre-lab. Okay?
So for multiplying it, you don't worry about the sig figs.
Correct.
Just decimals.
Correct. Yep. All right. Yeah. So if you need to see it, I guess if you just need the visual real quick. So carbon was 12.011, so I would put that in there. I'm going to add it to, you can either put oxygen twice. You can either just add oxygen plus oxygen, or you can do a quick little multiplication. Okay? But remember that 2 does not count as your significant figure there. Okay? You're going to add those together, get your molar mass of 44.009, and you're going to label it gram per mole. Okay? Gram per mole. And that's what a molar mass is. It's the mass of 1 mole of that stuff. Okay? So, and we're going to get into the mole on Wednesday. Okay? And then most of Thursday, Friday is review for semester exams, so we're not going to go too far. All right.